Have you ever had mayonnaise on a burger? Or maybe on a hot dog? Surely you've also had milk before. Or maybe you've had a salad with vinaigrette if you're feeling fancy. All of these are possible because of the process of emulsification.
You'd probably expect emulsification to be named after a white man named Albert Emulsine, just like how pasteurization is named after Louis Pasteur. But no, there's apparently no person to credit apart from the Latin language. It comes from the word emulgere, which either means to milk out or to drain. And honestly, kind of sounds like a Pokemon.
Emulsification is a physiochemical process in which two immiscible liquids are dispersed into one another to form a stable mixture. In the context of food chemistry, emulsification plays a crucial role in creating consistent textures and improving the stability of food. The emulsifiers, or stabilizers, reduce interfacial tension and prevent phase separation, keeping them from separating and thus influencing the overall microstructure and stability.
Huh?
Okay, so to put it simply, ooga booga, normal, water, oil, no mix. But emulsification, ooga booga water, ooga booga oil, mix.
We've been talking so much about what emulsification is, but okay, what about it? Emulsification works through homogenization, where two immiscible liquids are forced to interact. Kind of like setting your friend up with that one girl that doesn't even like him. Your buddy here is oil, and the girl he likes is water. In a more literal sense, the relationship between oil and water is a great example of immiscible liquids, because as we all know, it's hard to mix them.
That's where emulsifiers come in. These are amphiphilic molecules containing both hydrophobic and lipophobic parts that help pack the oil and water molecules together while preventing them from remerging. It's essentially a bridge that helps connect oil and water molecules together. For example, your friend and his crush find out that they both enjoy chemistry, so they start bonding over it. That similar interest is essentially their emulsifier.
Plus, there are a lot of emulsifiers out there, some well known examples being egg yolks and surfactants. They help with things like foaming stability and contribute to texture and structural integrity of food.
You may not see it or feel it, but there are a lot of foods that do use emulsifiers. Aside from the overused example of mayonnaise, take ice cream for instance. The weather is enough to make college students have heat strokes left and right amidst the absence of suspensions, making it perfect for ice cream. But what makes ice cream, well, creamy? Emulsifiers. Monoglycerides help the fat mix with water, keeping the ice cream more compact. And because of the way it's all packed together, we don't get air bubbles in our ice cream, which means that the ice cream stays as ice cream and not creamy ice. I mean, it's cold, but it's not ice cream, it's frozen milk.
Emulsifiers really do help maintain the structure of food, like other desserts, candy, chocolate. All that sugary stuff needs emulsifiers to exist all in one piece, to be exact.
Speaking of sugar, we use emulsifiers in baking too. After all, a lot of recipes use fat like oil and butter, along with some water. Then emulsifiers come in, like lecithin and glycerides. Lecithins are the reason why bread loaves aren't built like bricks. They're natural surfactants that help stabilize air bubbles to make bread more airy. These, along with glycerides, can help make smoother batters, creating more moist and fluffy pastries.
And we can't forget about the vegans. Vegan friendly emulsifiers like lecithins again can even be found in alternative products like vegan meat, soy milk, and condiments to keep all of their ingredients together. And, of course, to keep the vegans from starving to death.
Thank you, Jesus.
But really, why do all of these even need emulsification? Even if we're just literally explaining it the whole time. Okay, but in all seriousness though, the structures wouldn't be stable. Again, like in mayonnaise, increasing the emulsification intensity breaks the oil into a finer disposition of droplets, giving you smoother textures and more stable mayo. So other than looking appetizing, they taste and feel better. They even live longer. And that's how I know you've got good mayonnaise. It's smooth unlike my face.
So, mayonnaise, emulsification. Ice cream, emulsification. Cake, also emulsification. You and your crush? Well, that's a different story. Emulsification plays a huge role in keeping things together, but sadly, it can't do the same for relationships.